Good afternoon friends, welcome to the course again. Yesterday we did measure of central tendency for describing the data. Today we will be doing measures of variability. So, what is variability? As we talked about, these are the various ways we can measure the various measure of variability. Okay. Now, please look at the figure here carefully. Let us not get into the shape. The main thing is the mean of both of the graphs is same. So, if we just talk of central tendency of graph 1 and graph 2, that will be causing an issue because both are equal. So, are they equal? No. And that is the example I gave you yesterday about the plot. Two plots of 1 acre and 5 acre might be located at same place. So, that the location of GPS might be telling same thing, but it is not telling about the size. Hence, we need measure of variability. Now, these are the measures of variability, okay? Range, interquartile range, variance, standard deviation. Most of you might be knowing most of them, but still we will do for it for a more proper understanding. Okay, the range is very simple, the maximum minus minimum, that is it. In this case, 14 minus 1 is the range. Now, it does not include the mode and everything, it just includes the extremities. So, that is one way to test the variation or tell us the variation, why the central tendency is this, the range is this. Okay. Now, what are the disadvantages of range? As we can see in the both figures, the first figure there are 5 elements, there are 6 elements and they are equidistant, their average is around 9.5. On the other hand, if you see the same data, you have 6 entries, okay. The range is 5 again. So, now can we just say if we just calculate the range, are we able to describe the same data? Same range means, so please understand, neither same range, neither just measure of variability, nor just measure of central tendency are sufficient. And as there was changes or challenges or different use of mean, median, mode, similarly there are different uses of these measures of variability. Okay. As again we see, it is very sensitive to outliers as the mean was in central tendency. Okay. So, the sensitivity, if it is not there, if the data is quite homogeneous, not that much separated by outliers, then we can go for range. Otherwise, neither we can use mean nor we can use range here. Okay. So, that is the disadvantage of range. Easiest thing is advantage is easy to calculate. There is no average everything and standard deviation as it is required. Okay. Now, this is very interesting. We did touch about this in the box plot and we did mention we will discuss it again. So, what does quartile means? Quartile means when you arrange the data in an ascending or descending order, just like the median was 50%, quartile is 25%, 25%, 25%. There are 4 quartiles, as simple as that. Do you understand this? So, let us just say median was there, it is a 50% 50 percentile. Okay. So, quartile is 25%, 25%, 25%. It's very simple. Now, why this is needed? Because many a times we say this is practically happens in placement. Okay, among the class, they do not ask my rank because rank is something very dependent on the number of students. So, if there are 100 students, if I say my rank is 14, okay, that will be very much different if there are 20 students, I say the rank is 14. Therefore, sometimes the rank is not asked, sometimes just ask you are in which quartile of the class. Okay. So, the first quartile, the second, the third, the fourth. Okay. So, in that ways quartiles helps us to understand the relativity of the data, okay, not just rank. Okay. So, this is very simple as it was there in the median, the n plus 1 by 2, similarly 0.25 into n plus 1, 0.5 into n plus 1, 0.75 into n plus 1. As simple as that. Okay. This is very easy, nothing to worry about. Okay. Here we have an example. See, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 positions are there, n is 9. So, the median is 16. Okay. If we take the cursor, the 16 is the median. Now, when it comes to quartile, so as we say 0.25 of n plus 1. So, 2.5 position. Okay. So, 2.5 position here means this, as we have mentioned in the this. So, that is average of 12 and 13, which is 12.5. Okay. These are the measures, and we will see, as again there were criterias of understanding how to compare measures of variability, a measure of central tendency. These are the measures to compare measures of variability. Extreme course, like in the range, if you expand the range, if you change the last element of outliers, the range will change. Okay. Stability under sampling. Under sampling, this is a topic of sampling. Like if I have people of like group of 1000 and I take a sample of 10 and 10. So comparing the means measures of variability. So as we talked in central tendency, there were ways of comparing it, and some of them were like how it is stable across to the sensitivity or to the outliers, how it is stable across sampling. Similarly, there are factors here. So extreme course we have talked about, the variability due to adding the outliers. Stability in the sampling, this is very important. So suppose there are 1000 people and I am sampling 10 people at one time. So when I sample 10 people at one time, their range is suppose R1. Now again I draw a sample of 10 people, the range of that is R2. Now the difference between R2 and R1 should not be very large. Okay. Therefore, please understand, this is called stability under sampling. Different, and this is what we will study when we will study for sampling distribution, not just frequency distribution. And what is the sampling distribution? Okay. And sample size, obviously, this is very important. So let's say we have 1000. In our last case, we had 1000 population. Now, if we are drawing a sample of 999, 999 or 990, 990, then obviously range is quite stable variable. Range is quite stable measure of variability. However, if the sampling is small as compared to, then we have to look for other variables. Okay. And this open-end distribution, we will discuss about this when we have to talk about frequency or sampling distribution. Okay, this is very important. I will just tell you this. What is moment? So if you go for, this is little mathematical, and I am just telling you for information. Xi is the value of ith variable. Okay. The moment means how much far it is from a particular point. So please look at the word moment from the origin, moment from the mean. Okay. So we are talking about moment about the origin. So what is mean? X minus 0 and summation of xi minus 0. So this is moment about the mean, origin. Okay. Now when we talk about yesterday, just we talked about summation, that we also have a measure called average deviation, and we said average deviation around the mean is 0. So this is xi minus x average. Okay. Summation of this is also first moment. What is first moment? First moment is the power to degree to this, like the power here. Here the power is 1, here also the power is 1 or degree is 1. So both are degree 1, hence both are first moment, but first one xi minus 0, let me increase the font size. Xi minus 0 is the moment around the origin, xi minus x average is the moment around the mean. Okay. Now when we go for second, so if we say this is first moment around origin and first moment around mean. When we say summation of, please understand this is very important, xi minus x average star xi minus x average. Okay. So now this is actually square. So This is not first moment around the average or mean, this is the second moment around the average. Okay. So, please understand, I introduced this concept of first moment and second moment because ultimately as we go on we need to understand how different things are related to the moments around. Okay. So, please understand, first moment around the mean, second moment around the mean is variance, third moment is skewness, and fourth is kurtosis. What is skewness and kurtosis? We will talk about it more when we go on the sampling frequency distribution and normal curve. We will describe these things, okay, in detail. Right now, nothing to worry about. This is a new concept. Generally, people don't know this, but this is very important that we know that it is all in moments, and higher moments are preferred in reporting the variability of data, and we will see that. Okay, coming back. So, that is fine. Now, coming back, interquartile range, as we discussed in the box plot, if you remember the plot series in week 1. So, interquartile range is third quartile minus first quartile. Okay, the third quartile minus first quartile, that is it, or 25% to 75%. Okay, that is the interquartile range. Okay. So, it calculates 50. The point is interquartile range, it consists of 50% of our data. Therefore, we study interquartile range because extremities are also part of the quartiles, the fourth quartile and the first quartile. But if we just take, okay, this is range is different from interquartile range. Range is the difference between minima and maxima. Interquartile range is difference between the first quartile and the third quartile. Okay. So, that is also a nice way to explain a measure of variability. Okay. As we show in this case, median is 45 and interquartile range is 27. Okay. Now, there is as I was telling you, there is some issue with the slides, no problem. Mu and xi have combined in each other. Anyways, look at the formula on the right hand side. Okay. So, this is a square deviation. Population variance, what we were talking about, is a second moment. Okay. So, mu I is a particular entry now. Okay. So, population variance is a C here, xi minus mu I whole square, that is the formula, that is what we discussed here in the figure, xi minus whole square. Now, let me write the formula. Variance is xi minus x average star xi minus x average divided by n. Okay. That is what we have to rectify. Now, what this weightage means? Sometimes the values have different weights. So, when we say particular xi is not just one, there are multiple xi's, like one number is appearing thrice or 4 times. So, that the weightage of the variable increases, that particular data increases. Okay. So, now this is very important. This is the proper formula, the n minus 1 is there, that is all. N minus 1 is there when we have a sample mean, and population mean is only divided by n. So, why it is n minus 1, why it is n, and we will talk about this more in detail. This n minus word will stay with us for quite a long time in statistics, and we will see this. This is called degree of freedom. We will touch upon that today itself, not right now, but in further sessions. Okay. Okay. Now, this is very important. Variance and standard deviation are different. What we discussed was variance. Standard deviation is root of or under root of variance, and this is most important formula. You might say standard deviation sigma, which comes in Excel, it is standard D dot DEV, that we will see, and it has same units as the original data. So, never ever we say standard deviation is 0.3, 0.4, whatever the value is coming, we say 0.3 units of the original data. So, mean is also not 2.5. So, if I have 1 kg, 2 kg, 3 kg, 4 kg, 5 kg, the mean is 3 kgs. Okay? So, please understand that. Again, if we have sample variance, so we have sample deviation also, sample standard deviation, same, divided by root. Okay. Now, let us look at the sample variation, this. Okay. So, we have 12, 12, 14, 15, 17, 18, 18, 24. Okay. And this dot dot in between includes the square which leaves multiple entries. Okay. As n is 8, so denominator is 8 minus 1, 7, and hence this value. Okay. Now, this is what we were trying to tell you, but the standard deviation is different. So, standard deviation, lesser it is, more the data is around the mean. What is standard deviation again? Standard deviation is root of variance. What is variance? Second moment around the mean. So, if standard deviation is less, variance is less, that means the deviation or the moment from the average is less. This is called standard deviation being less. So, small standard deviation and large standard deviation. So, small standard deviation, the data will be more around the mean, please understand. Large does not mean it has to be large in size. Large means deviations or spread, the measure of variability, the spread is more around the mean, that is large standard deviation. Okay, let us check from this example. Okay, all of these data have similar means. Please understand this, you can check it, but they have a different standard deviations. And as you can see, the point B, the standard deviation is 0.926, makes it near to the mean. So, 15.5 is the mean. So, around it 14, 15, 16, 17, the data is lying. So, please understand, small standard deviation does not mean small spread. Small standard deviation means small spread around the mean. Okay? Please understand this. That is very important. The value is very simple. Each value in data set is used in calculation, that is one. Now, if you talk about average deviation, which we had in our the central tendency, here we have a deviation square. So, when we have deviation square, what happens is the sum of the deviation square is not 0. In the mean case or average deviation, the sum of average deviation is 0. So, you can't find too much things. So, therefore, because deviations are squared, therefore, you have a concrete understanding and every value get weightage, because if it is multiple times it will get repeated. Okay. So, that is the advantage of to measure variation not by average variation, but by standard deviation measurement. This is very important, coefficient of variation. It is very simple and we will talk about this important. This is even more important than the standard deviation, and this includes both standard deviation and the mean. What is this? It is just a ratio of standard deviation on mean, that is it. Mean has same unit, standard deviation has same unit as the original data. So, coefficient of variation is unitless. Coefficient of variation is unitless, hence it is much more useful thing to be applied. Okay, and we will see how. Now, see here, the average price of the stock is 50 rupees and the standard deviation is 5 rupees, as compared to average stock price of 100 rupees and a deviation of 5 rupees. Now, if you just look at the standard deviation is similar, yes, standard deviation is similar or same, 5 in this case, but the coefficient is quite different. One is 10%, one is 5%. And again, as I was telling you, it is unitless, percentage is unitless. Okay. So, lesser the standard, lesser the coefficient of variancy, stable is the price. Okay. So, I can say 10% data varies in A, when in B I will say 5% around the mean it will vary. 10% around the mean it will vary, I will say in A, and in B I will say it will varies around 5% around the mean. Okay. So, next we will talk about their score and standardizing their data and degree of freedom. Thank you very much, and we hope to see you in the next class.